Hello everyone. So in the previous module, we discussed about RAG, embedding, vector DB and semantic search. So in this section, we are going to deep dive in retrieval augmented generation RAG. So retrieval augmented generation or RAG is a powerful architecture where language models like GPT don't just rely on their internal memory. Instead, they first retrieve external information from a knowledge base, then generate a response using the data. So essentially, RAG is equals to LLM plus external knowledge base. This means the model becomes more dynamic, factual, and context aware. Why do we need RAG? Traditional prompt engineering has serious limitations like knowledge cutoff. It means models cannot access events or facts beyond their training data. Second, hallucinations. They often generate incorrect or made up responses. Third is lack of transparency. We do not know the source of the answer. So, RAG solves this by adding a retrieval step so the model pulls real time external data before answering. This makes response more accurate, grounded, and explainable. Core concepts of RAG. RAG works in four simple steps: chunking, data insertion, user query, retrieval plus generation. So, in chunking, we split large documents into small meaningful pieces. Data insertion means these chunks are converted to embeddings and stored in a vector database. User query: the user asks a question. And retrieval means relevant chunks are retrieved and passed to LLM, which then creates a grounded response. So this structure allows the model to answer question based on external knowledge, not just by memory. So in this part, we will break down the complete RAG architecture into two main stages. First one is indexing and another is retrieval and generation. Indexing is what where the knowledge is prepared, and retrieval and generation part where the user query is answered using the knowledge. Okay, so we will use this simple visual diagram to walk through each part. Let's get started. So first up, indexing. Imagine you have a large document, say a research paper or a company manual in a PDF format. We start by loading this document using a document loader, but reading a giant file all at once isn't practical. So we break it down using a text splitter. This splitter breaks the document into smaller chunks, kind of like paragraphs or sections. Each of these text chunks is then passed to a embedding generation model. Think of it like converting human language into machine language, more specifically into embeddings. These are high dimensional vectors that represent the meaning of the text. Once all the chunks are embedded, we store them in a vector database, a special database built to search for similar meanings quickly. So, now we have transformed raw text into structured, searchable knowledge. This is the foundation of RAG. Now comes the second part, retrieval and generation. Let's say a user has a question. This question is taken in as a query, and just like earlier, it is passed through the embedding generation model to convert it into query embedding. Again, a vector that represents its meaning. This query embeddings is now compared with all the stored documents embeddings in the vector database through a similar search. The system finds the top k matching chunks. These are the pieces of information that are most relevant to the question. Now, these chunks, along with the user's query, are passed to LLM, the large language model. The LLM reads the question and the supporting documents, then generates an answer that is both natural and grounded in the retrieval content. And finally, this answer is delivered to the user, not from the model's memory but backed by real data. So to summarize, RAG is equals to LLM plus external knowledge retrieval. It solves a major limitations of traditional prompting like hallucinations, outdated knowledge, or vague responses by retrieving accurate information first and then generating the final output. This makes RAG an essential architecture for chatbots, customer support, legal assistants, research copilots, and much more. Hope this breakdown helped you understand the heart of how RAG works. Further, we will see these topics like hallucination, chunking, embedding, saving data in vector database, user query, and retrieving the best chunks in much more detailed video. What is hallucinations in AI? Let's start with a common issue in AI systems, hallucinations. Hallucinations happens when an AI confidently gives a wrong or made up answer. It looks believable, but it is not true. For example, if you ask who is the Prime Minister of India in 2025 and the AI replies Elon Musk, that is a hallucination. This usually happens when the AI doesn't have updated or accurate knowledge. And that's exactly what RAG is built to fix by helping AI retrieve real facts before generating answers. Thank you.